Alright, I think I got this phone set up in a way where I can record the arcs properly. So we're going to see, but I was waiting to get these FETs that I ordered. So these are the ones that I showed in the last video. They're 100 volt, 110 amp little SMD guys. They probably, come in the through hole package, right? But I was just too lazy to look it up. And so I just kind of set it up the same way as I've got my, basically that guy right there set up sort of the same way using the same switches. Just kind of sandwiched in there. Actually, I bought a few of these a while back. I haven't actually used them for anything. These are just little gate drive transformers you can buy. They've actually got two outputs. So you could drive like a half bridge probably fairly nicely with those, right? With small switches. So I just paralleled out the outputs, and it's a 1-1, and it's just smaller than this one, right? So that's just why I'm using it basically. I guess you can see I've just got a couple, what are these, like 15 ohm resistors going to the gates. Again, probably not absolutely necessary. I usually don't add them. And basically what I've got here is the same coil I had before, but that's the top load I've got for it now. It's actually a whole lot more similar to that one. You can see this little portion right here is there's no windings taking up this little space right here, so it's like an inch of distance from the top winding. And I've also wound this one, so I'm going to throw this smaller guy on the other circuit, and I might actually play with some SIG FETs or something like that on another one. But when I was first playing with this circuit and with the other setups I had, I was using this primary. So I was down to these 2 turns, and that's basically a 100 microfarad or 100 nanofarad capacitor, just 2S2P basically. And I've got the scope hooked up just to show the drain waveform. So I'm just going to show what it looks like this time with, with this type of tuning. So again, as you can see, the first primary I used was actually, let's just say the diameter of this one's quite a bit wider. So the coupling is not as high, and it's just kind of sort of sitting in a random spot right now. So I haven't really quite adjusted that. But I just wanted to show that, so once I got this set up to get going, kind of draw that out. You see the drain waveform, it actually resembles a nice Class E hump, right? Let's see, this is going, so this is going about 700, there you go, 730 kilohertz or something like that. So you can see it's actually already creeping up to about, 60, 70 volt swings, and these are 100 volt MOSFETs. So again, another thing is, like, you can kind of see this breakout point I've got. It's not a very long breakout point, right? But yeah, part of the reason I do that is because that helps me encourage the like the sword looking sparks like that, right? Let's see if I can cut them down. Cut the duty cycle down real low. Alright, so that's pretty typical. But again, let me see, so you can turn it up a little bit. So this is at the point where, so if I turn it up to 20 volts, I can about bring it to 100 volt swings. Now, it still doesn't really show up on the phone, right? Try that. I guess it's all the same. I don't know if I can, like, oh yeah, let me bring the brightness back down. I don't know, anyway, so I'm just kind of gonna, I'm not real sure about this tuning, but I'm just gonna swing it up a little bit. so that's 24, and I'm peaking just barely over 100 volt swings, right? Right, so again, at only 24 volts, I'm already peaking over 100 volt swings, but it'll probably be fine if I crank it up to 30 volts. I mean, I can't say for sure, right? But I'm pretty sure it could probably handle peaks of over 100 volts. You know, whether it's avalanching or not or whatever, I don't know. So yeah, I don't feel any warmth on these heat sinks at all, which is typically how it goes when I've got it tuned a particular way, pretty close to that, right? At the same time, that one over there is not quite tuned the same, but that's just because I nudged the coupling down to the point where I get the highest output voltage, and it just happens to be where it's like right at that point where those arcs start popping. The point is, you don't actually need a drain waveform that looks like that. A lot of times, you know, like there's so many different ways I can set this thing up where I'll get something close to that output, right? And the waveforms can actually look pretty crappy. But I'll say basically the point was when I was using this, what I was noticing was that at a certain, maybe a lower voltage and a certain coupling, I would see something similar to the Class E waveform, but it would have sort of this sort of like dip and rise back up halfway in between. And when I started seeing that, I thought, okay. And by the way, when I would draw arcs to the hand, it would start to, I would hear a lot of ringing in the output. It would sort of screech a little bit. And, you know, that's the type of stuff where you can get sort of decent output to free air, but maybe it'll screech to the hand. I just don't like that. So basically I was like, all right, well, let me increase the diameter of the primary now and then see what the waveform looks like. And it actually started looking pretty good, just with sort of this, you know, random guess that just happened to fit around this guy, right? So just an example of the tuning that I ended up with this particular setup, and I ended up using those particular fits. So I really don't want to blow them up, but I'll probably go ahead and just swing it up to 30 just to see what this thing can do, even with all this crap laying around. I'll cut the lights off first. All right, with lights down, cut it on, get it going again. So again, that's the waveform. And I'm just going to kind of watch to see what that peaks out at as I swing the voltage up. So again, we're about like 18, 20, 24. Oh, I don't know what that was. I'm not sure. I have to review the footage. What I'm going to do is I'm going to nudge that primary up a little bit. All right, so now it's up just a little bit, which essentially means that at the same voltage, well, let's see, I was at like 17 or something, but now that I'm at 20 volts, you can sort of see it's not really jumping out to free air. Whoop. It's not jumping out to free air anymore like that, right? All right, let me get it going again just to make sure it's right. All right. See, it's not jumping out to free air anymore now until I change the tuning like that, right? So I should be able to cut it up a little more now. So let me see what happens when I start trying to swing it. Actually, what happened to the waveform? Did I lose it? My trigger is messed up right now. Anyway, well, now let me fix that. All right, well, I can't see right now, so I can't fix it, but whatever. Now I've got the waveform on the screen, but so 20 volts now. Now you can see the arcs don't really come out till about 24. Okay, it actually started wigging out when arcs started shooting out the side. So around the 28 volt region, I'm already hitting about 150 volt peaks. So yeah, I'd say that's pretty good 24 volt output. But yeah, again, I could it'll be much better to free air if I just bump that down a little bit, right? So I don't. Oh yeah, let me feel this. Again, no warmth at all I can feel on here, but it's kind of like pretty thick copper little bus bars I sandwiched on there. But yeah, anyway, I know that some people out there, have a hard time with these, and I get it. But again, I mean, it's like if you're not getting good output, then you're just gonna have to keep playing around with it. Um, so like the best way I've usually put it was like, if you just sort of follow this general theme, then you're gonna end up with some type of output, hopefully. Um, and if you don't, then you might be able to get some decent output just changing a couple things, right? Like how many turns are I usually stick with like 2 turns to start with, right? Maybe 5 turns will work, maybe it won't, you know. But if you keep playing with it, eventually you're going to get to a point like I did, I suppose, where you'll be like, oh, hey, this is pretty good, right? And then from there, you start tweaking little things to where, so long as you have a certain output, some form of reference, then you can start tweaking things and seeing like, oh, okay, I can improve the arcs a little bit by doing this, or, I can get the output much more reliable and consistent, if I do this, things like that. So, again, like I can typically land on some random tuning that looks pretty good to me with nice arcs, but I usually don't end up settled with it until I get an output that I feel looks like that, where I can kind of go like this, the arcs jump out, hit my hand, they're pretty beefy, and I don't hear any weird artifacts in the output. And so it just so happens in this case, I end up with a decent looking drain waveform. It just starts peaking a little too high, once I get up to the 30 volt region, basically. But again, I've got other ones that don't quite look so clean. Some of them might resemble something like a dirty Class E waveform. The FETs will get hot over time. A lot of them running that type of output, the heat sinks would be warm by now. So, it's just an example. Like, I guess it doesn't really matter so long as you can keep it cool. But, it wasn't necessary to get sort of like a Class E looking drain waveform to get output like that, right? So, I don't know. Again, it's just, there's a bunch of different ways to do it, but that's just kind of how this one ended up. So, this is the whole point was to just sort of come up with something and settle with it, and then throw it on a little box like this, right? And then from there, I guess I'll have to figure out how I would power it. But yeah, not a bad little deal. So basically what I would probably do is keep running that tuning like that for a while, run continuous wave, do all kinds of stuff, right? Which, by the way, that looked like some pretty nice continuous wave. and you know, just do all kinds of stuff. See, like, okay, are these caps gonna be able to handle that? Are all the caps I've got, gonna be able to take it? And are the FETs actually, are they getting hot eventually, or what? What's going on, right? If everything looks good, then again, I'll be like, that's a pretty dang reliable build. Yet another one that's pretty simple that I can just, kind of pull out whenever, get pretty decent arcs. And again, a lot of times, these are the type of arcs that you might see from just a normally tuned mains coil about this size, right?